Download the startup code for Unit 2, Module 2, Lesson 2, Short Circuit, and there is a fast start activity as well. Do that first, and I'm going to you'll pause the video, and we'll continue from there. So, it was a fantastic movie in the 80s called Short Circuit. Absolutely worth finding on Netflix. Johnny Five, fantastic little robot. But not really what we're interested in today. What we're interested in is the concept of short circuit evaluation. And we're also going to take a look at De Morgan's law. So here's the startup code. And really what you have to understand is that Java is lazy. That's really the essence of short circuit evaluation. Java's lazy. Java will only evaluate what it absolutely has to evaluate to determine if the condition is true or false. So when Java looks at this condition, it starts here and says if y is less than 0. Well, if that's true, and Java knows this is an OR statement, it will not evaluate y greater than 100. It'll ignore that part. So it'll never, ever, ever get to this part. So a good example of this condition, it's very helpful, will be this. An AND condition, y is greater than 0, and let's do 17 divided by y is less than 0. Now, the reason this is important in terms of short circuit evaluation is that if y is not greater than 0, this is going to cause an error, a compiler error, because you can't divide by 0. So if y turns out to be equal to 0, we're going to get a compiler error. However, because of the way Java evaluates this, if this is false, if y is equal to 0 or less than 0, it's never going to check this condition. So you never end up with the compiler error. So this is one of the few times in the world when you can technically make it look like you're dividing by 0, because Java never gets to this statement. It stops here. That's the essence of a short circuit. It only evaluates what it has to minimally to determine if a statement is true or false. So with an OR statement, if the first statement is true, the entire statement must be true, regardless of the second part of it. It never needs to check it. So Java short circuits the condition and stops checking. As soon as it finds out that this is true, it short circuits the evaluation and does not check the second part. For an AND statement, since both of these conditions need to be true, if the first one is false, Java short circuits the evaluation and stops checking. And in this case, it has an extreme advantage in that you'll never end up dividing by 0. So this is a very good thing if you need to divide by a variable. This is a very important conditional for you. If you need to divide by a variable, it's important that you first check to see if it's greater than 0. Because if I wrote this conditional in reverse, if I wrote 17 divided by y, ampersand, ampersand, y greater than 0, in mathematics, these two would be identical. In mathematics, we're smart enough to know that both these conditions need to be true in order for this to be true. So we would say, okay, 17 divided by y, that's great. Whoops, great, less than 0. I should have missed half of it. 17 divided by y less than 0 and y greater than 0, that's great. That's fine. We're fine with that, right? We'd be okay with that in math class. In computer science class, if y was 0, we'd get a compiler error right here. The program would fail because you can't divide by 0. So the order in which we're testing this is really important. Java checks this condition first. And it will short circuit the evaluation and never get to the second part of the condition, so it won't have a compiler error. In the case up here, Java checks this condition first. And if y is 0, we're going to get a compiler error. So it's going to fail. So here's another one of those cases where in mathematics, we wouldn't care. There'd be no difference to us. But in computer science, there is a difference. There's a huge difference between these two things. One's going to cause a compiler error. One is not. So that's essentially what short circuit is. And it's a very subtle little thing. And there's a couple of those subtle things that we'll be looking at throughout the year, like the A++ versus the ++A. Another very subtle concept. These subtle concepts, you have to make sure that you go back to repeatedly. So this is our second very subtle concept that you're going to have to keep revisiting throughout the year. It's one of those things that you just have to keep double checking. All right, so in essence, Java uses short circuit evaluation to compute compound statements. It's a short circuit when it's an AND statement. If A is false, the whole thing is false. So it shorts out. It's always going to short out in the first condition. For an OR statement, if A is true, then the entire thing is true. Here's another example. We were just talking about if x does not equal 0 and y divided by x equals 10, this avoids dividing by 0 because it short circuits here and will never look at this condition. It never sees that second condition. It only sees this condition and then stops evaluating. So next part of our lesson today, De Morgan's Law. All right, so this sounds horrible, but it's awesome to say at cocktail parties. It's the negation of a conjunction is the disjunction of a negation, or the negation of the disjunction is the conjunction of the negations. Yeah, I know. Isn't that awesome? Like if you could say that at a cocktail party, just like rattle it off. What the heck does that mean? Okay, well, or not A and B is the same as not A or not B. Absorb that for a second. Not the quantity A and B is the same as not A or not B. So let's look at what actually changed there. We switched from an and to an or. And the not was applied to both the A and B. The or works identical. It's the second part of De Morgan's Law. I don't know why they didn't just generalize it and make it one law, but it's really two parts. Not A or B is the same as not A and not B. So to explain this further, Venn diagrams are helpful. So there is a video that are just below this one that I would like you to pause this video and watch that video first, and then come back to this next video. Okay? So come back to the next video after this. I'm going to stop this one, and then you can watch the De Morgan's Law.